Welcome to lesson 1.8, and we're going to be talking about inverse functions. So a lot of this we did touch on last year in Algebra 2. Um, we're going to expand on it a little bit here. Let's take a look at the objectives. We're first going to verify inverse functions. So take two functions and determine if they are inverses of each other. Then we're going to look at, given a function, what is its inverse? And then we're going to use the horizontal line test to determine if a function has an inverse. We're going to use the graph of a 1-1 function to graph its inverse function, and then find the inverse of a function and graph both functions on the same axis. Okay. So the first part of the objective was, determining if two functions are inverses of each other. If you recall back in Algebra 2, we did talk about composite functions. So a function being evaluated for another function. A function is an inverse of another function if you compose them and the result is x. So let's take a look at what we mean. So for instance, if you have f of x is equal to 4x minus 7 and g of x is equal to x plus 7 over 4, you test if they are inverses of each other by composing them. So f of g of x is taking the g function and substituting it in for x in the f function. So f of x plus 7 over 4, in this case, is going to be 4 times x plus 7 over 4. That's the g function substituted in for x in the f function, minus 7. The 4's would cancel out. Then the 7's would subtract away to 0, and you're left with x. So it works for f of g of x. Then you try the reverse, g of f of x. So now you're substituting the f function into the g function for x. So g of 4x minus 7 ends up being 4x minus 7, which is now substituted in for that x. Sorry. 7 subtract away, you end up with 4x over 4. The 4's divide away, and you have x. So because you were able to get it to be simplified down to x for both composite functions, f of g of x and g of f of x, then what you can determine is that the f and g functions originally are inverses of each other. If anything else were to happen, if any other result when you compose the functions, you get anything other than just x, then they're not inverses. All right, so then let's talk about the steps to find an inverse given one function. All right, so the first thing you do is replace f of x with y. Then you interchange x and y. Then you solve for y. Okay. If it turns out that what you have is a function, then you can simply just rewrite it with function notation. So you take y and you replace it back with f inverse of x. So if this is the function that we're going to find the inverse of, first thing you do is switch out the f of x for y. Then you interchange x and y. Right? So x is now where y was, y is now where x is. Now you take that function and you solve for y. So we'll subtract 7 over, and then you divide by 2. That is a function, so we're going to rewrite it in function notation with f inverse of x instead of y. So f inverse equals x minus 7 over 2. We can look at a horizontal line test to determine if a function has an inverse. So if you think about it, when you flip x and y to create the inverse, you're going to flip the function on its side. So something that would fail a horizontal line test would then fail a vertical line test if you flipped it. So simply if I look at a horizontal, so you think about the horizontal line test like you would a vertical line test. Does it touch the function more than once? A horizontal line would absolutely touch that first function more than once. So it's not a function. A horizontal line will only ever touch the second function once. So B has an inverse, A does not have an inverse. The graph of F inverse is a reflection of the graph about F about the line y equals x. So it's going to reflect across y equals x. So basically you would just, if you were to recreate f of x as an inverse, you would just take the ordered pairs and flip them. So -3, -2 would become -2, -3. -2, 2 would become 2, -2. 4, 1 would become 1, 4. Okay. So this point here, oops, sorry. This point here became this point here. This point here became this point here. This point here became this point here. You're just interchanging the x and y. You're just flipping the ordered pairs and replotting them. Okay. And if you were to put them on the same graph, they would mirror over y equals x. And that's it. Um, give the practice a try. Obviously, I'm available for questions. You know how to ask questions, whether it's live or through email. So give it a try and let me know how I can help.